Hey everyone, I'm Rishav. This is the future of production at Anode. I hope you enjoy my slides. A little bit about me, I'm mostly a self taught dev, learning like everyone else. I'm really excited to talk about what I've learned by working in the production part in Anode. Um, so, the improvements we have already made are we have already built a reliable, scalable production environment. We have already containerized all of our applications, so devs who need to run in local environments can run them easily. We also use AWS native services for deployment, and we have already implemented our automated CI/CD pipeline to enhance quality control and code control, make sure we pass all our unit tests, and make sure that it's per quality before merging into the main, right? And also, we have really improved our PR integrity through enhanced review processes. So we have more than early before we only had one reviewer, but now in our team we have about two more reviewers. So that means the PR merges are moving up to speed. Um, I guess from that we can kind of talk about like the current bottlenecks in production, what we can improve. The ingestion throughput scales to millions of PDFs per session, with current usage levels reflecting early stage infrastructure configuration, and labeling handles millions of documents, but overall throughput remains suboptimal due to bugs. So as we are scaling up as a company, we need to we want to perform in our full capacity. So these little bottlenecks we will in production, or as someone supporting production, right? We can definitely squash these bugs and move forward to let Anode perform at full capacity. Um, Also, our development infrastructures, we don't really have a testing isolated infrastructure, but as we scale up, we can think about adding a sort of a development infrastructure where devs can, test features and ideas on that infrastructure instead of breaking production. But we are slowly moving up there, and with the other thing I noticed was our infrastructure management was pretty manual. So in the future, we can definitely automate using infrastructure as code or Terraform, so that we don't have to go to AWS to manually deploy things and consistently do this manually. And also that will help our productivity and efficiency as an enterprise. And other than that, like developer velocity can also be significantly improved, right? We are context switching a lot, so like we can have one unified systems so that we can work on one system, so that our efficiency and production is at a higher level. So this is something, this is like a simple architecture I sort of like thought about for the development infrastructure. So this is just like a AWS infrastructure. So I have a AWS Cloud Region, VPC. Basically, what happens is a dev, commits code to the code base, a simple change to the code base on the development branch, and it triggers this API on that automated CI pipeline, and that hits that invokes the API gateway, which in turn invokes the Lambda function, which is like a serverless function, and that triggers the EC2 instance for the time being. Uh, Spinning up EC2 instances in AWS is quite expensive. So keeping that cost in mind, I thought about, okay, maybe we should have a start and a stop timer. So when a dev tests their idea, or the newly pushed code to the EC2, they can just set a timer and they can run that, and then the instance can slowly run. And along with that, we have also RDS, but RDS will run in conjunction to EC2. Um, so this is basically our API gateway, right? So this is the endpoint we're going to be invoking, the launch endpoint, and that's going to trigger a Lambda. Uh, response. So on this right here, we have a Lambda structure where the API gateway sort of like triggers the invoke Lambda trigger. And this is the boilerplate code for the Lambda that sort of like gets invoked by the API gateway. Um, and that brings me to like a faster rollout and in the future, right? So our so far we have been building a lot of products and we're pushing it to production, but as we scale up we want to be even more faster. We want to build fast, so like we want to move for like something rapid dev environments for faster iteration. So some of the things I noticed was while running like GPU intensive workloads, we could utilize something like EC2 based Jupyter notebooks, and that can definitely help us um, run these heavy GPU workloads faster and also handle like fine tuning such as like Dino V2 model, which was quite intensive using Colab. So we could actually fast forward that using Jupyter notebooks. And we're already using AWS native tools, but we can also integrate like SageMaker once we are using all these AWS native tools. And also we can enable like sandbox isolated testing environments, which was kind of what I was talking about previously, but this can be just for like GPU intensive work. Um, so so far, my goal for anode upload is to be greater than 1 million uh, uploads, and then also for data labeling, we want to reach above 1 million in the future, right? So it's scalable data ingestion at a million scale. Um, we also want to streamline scalable labeling workflows. So right now, baseline manual tools are Google Colab right now. So we can use AWS optimized scalable labeling pipeline, like I said, and the benefits can be it can be higher throughput, like lower latency, and we can also reduce the overhead cost. Um, and for the long-term future, we have integrate intelligence into the engineering workflow. So I feel like in the in our workflow we have a lot of AI opportunities. So that means we can really integrate a lot more AI into our workflow, especially while we are working in our dev environments and engineering workflow, and that can help us like accelerate code reviews with AI summaries. We can integrate PR agent. PR agent cannot replace like the traditional PR reviews, because we do need PR reviews when we merge to the main, but I think that PR reviews can kind of like take away the mundane task of like quality checking and all that, and that lets the dev who's reviewing the PR just focus on the more important parts of the PR. And we can also unlock sprint insights to dev dashboards and anometrics to platform monitoring. Um, and that kind of brings me up to my like a IDP platform, which is like we're kind of trying to shift to a more like a platform engineering, because in the early stage it's smarter to adapt to a platform engineering and IDP, because we have a unified development experience. So IDP is basically where everything is in that one platform where we can handle our APIs, our docs, our team and workflow. So the benefits of IDP are like their central service catalog, and they help streamline access to tools. And then as we move through, the long-term vision includes like fully automated environment provisioning from the IDP. So if someone makes a PR, we can just go to the IDP and sort of like go through the IDP and look through the PRs and check what team is making, what are the code metrics, how many PRs are being merged every day, etc. Um, and that brings me to the backstage. Backstage is the IDP that I was thinking about integrating into the workflow. So you can see like there is API, all the APIs are sort of like are listed below, and you can see the life cycle, description, tags, and action. So as you can see, Team C has a depreciated life cycle for that description. Hello world, right? So this is not to anode specific, but this is just a demo. But this kind of gives an idea like how we can utilize IDPs on our platform. Um, and then cost and ROI consideration, it definitely like frees up like developer time by using AI to automate routine tasks like PR summaries, commits, and deployments. So, and we can increase product throughput and efficiency by enhancing document handling with predictive labeling. And also we can minimize technical debt and simplify debugging through consistent deployments with infrastructure as code and centralized monitoring. I think it's really smart to remove all the technical debt early on as we are scaling up, because that will be very crucial for us as a company. So kind of want to show like a simple demo of this like quick um, this development idea I have. So a developer basically makes a push to the repo and creates a PR. Just gonna skip over this dependencies because it takes a really long time. Um, so right here, basically, I am creating a YAML file on the GitHub workflows, and in that file, that's where my API gateway gets triggered, and which that calls my Lambda function to run that instance. So once the dependencies gets installed and the PyTest runs, then we can see that in the next slide, we can see that the test runs and then it triggers that test environment. So it triggers a EC2 instance, but the use case can be different because um, we can either use the EC2 instance, we can just have a EC2 instance spinning up and we can just start a start and a end timer, or we can create a new EC2 instance to test our feature and production uh, feature and ideas on the server, so that when we are merging to the production, things are not breaking and uh, we're working through it. But yeah, so that's mostly my ideas so far. So yeah, I guess the takeaway uh, for my learnings has been that production environment is extremely different than the development environment, and we should always make sure that there is change in environment variables, and make sure that we push clean code and there are no secrets committed. So this is mostly my vision for anode production, which is going to speed up production and also help us like move fast with sprints. So yeah, thank you.